How are you, everybody who is watching this video? My name is Olenjolai from beautiful, fantastic country that called United Republic of Tanzania, eastern of the African continent. I'm very happy and I'm very glad to welcome you onto this, our online advanced secondary school, which is called the Tanzania. Welcome into Tanzania Online Advanced Secondary School in square bracket Olenjolai. And also, I'd like to take this moment to welcome you on our YouTube channels, our official YouTube channels that called Tanzania Online A-Level Circuit School. So here we do have SEC. This is S. Okay. This is E. Okay. Circuit School. And this is C. So SEC is abbreviations of the word secondary, right? And then A is abbreviation of the word advanced. Okay, I would like to remind you quickly the vision that we have in this platform. I'm very happy, first of all, to be with you. I'm very happy to be a part of your learning process, and may God bless you abundantly. So I would like to remind you the visions, the purpose. Why are we doing this one? You can ask me many questions, but many of them, my students, they used to ask me, Olenjolai, why are you doing this? What the main purpose? What are you seeing? What is the main, what is your focus? Where are you going? What's your passion in this? Well, so this is the vision that God has revealed in my heart, that God has told me that I should prepare a special group of students who will be ready to combine the knowledge gathered in the classroom instructions in mathematics, either in advanced mathematics, for this level in advanced mathematics, basic applied mathematics, and science subjects such as physics, chemistry, biology, agriculture, and other subjects that will be start learning them yourself. Combine that knowledge that you get in the classroom, which I'm going to teach you, and even some other teacher will teach you, with the knowledge of the Word of God, the Word of truth. When I say the Word of God from the Bible. So, after you combine them, so you know what will be next? Then we want our students, when they are still in advanced educations or they after graduate advanced education, they combine the knowledge of mathematics and science that learn in the classrooms or even outside the classroom, right? With the knowledge of God, knowledge of the Word of God, the Word of the truth, okay? In order to solve real life problem. Either plural, which means either problem or problems, right? So that's our main. So in simple sentence, we like to prepare a special group of students who are ready to take the classroom instructions, combining with the instructions of the Word of God in order to solve real life problem. In brief, that's the vision that is in my mind. So I'm doing all of this. I'm pouring out myself because of that. I want to achieve the main objective of these online schools of Tanzania Online Advanced Secondary School is to see our students solving real life problems. We have some specific objectives. One of them, we help our students to pass the test, pass the terminal exams, the annual exams. We may even sometimes compose some of the exams for them. So we want to help the students, regardless of their level of understanding, whether they are slow learners or they are intermediate learners or they are faster learners, regardless of your level. God has given me different teaching aids that I'm going to use in order to balance it. Every student is going to understand what I'm teaching him or her, whether you like or you don't like. Right? So that's the point that you have to make sure that you remember. Okay, so I'm not allowed to go into too much details concerning about the vision, the main objective to see students solving real life problems. Some specific objectives we want to see our students, they are graduating successful with their high performance in mathematics and mathematics, physics, chemistry, and basic applied mathematics. So that's the main objective that we have, or one of the specific objectives. And then will be awarded a certificate. But our main objective is not just to help you to pass exams. That is one of our specific objectives. Okay, I would like also to take a moment to welcome you into one of our departments. Currently, we have 3 departments in this in Tanzania Online Advanced Secondary School. but we still have some other departments which are still in constructions, right? This is the online course, is not a physical school. The subject that we are teaching you, so we are in departments of advanced physics. We have another departments of advanced mathematics and advanced theoretical chemistry. So the subject is advanced physics. The main topic that we are teaching you is electrostatics, and this material is for the Form 5, for the pre-Form 5, for the Form 5, for the Form 6 or Class 13, pre-Class 13, pre-Class 16, and even Class 14. Pre-Class 14, Class 14, pre-Class 13, and the Class 13. So the topic we are learning is the second topic. So this is the second topic, which is called it's the second topic. It's called the electric force. And we are in session or lecture 9. And this is titled as problem solving, right? Problem solving in electrostatic, in laws of electrostatic. Problem solving, we said that, yes, problem solving of electrostatic, of electric force. We are still in electric force here. So we did the 11 examples with you. So now, allow me, ladies and before that, I would like just to do the quick review, to link this session with the previous session. So quick review of what we have in this channel, our YouTube channel currently, we have sessions labeled in session 00 to session 8 or 40 electrostatic. Session 00 is universal. It means that it's a universal session for all the topics of advanced physics. And it's called the General Introductions of Advanced Physics from 5 to Form 6. And then, basically, we taught you about 3 laws. Okay, from session 0 or from session 1 to session 8, we taught about fundamental law. The fundamental laws state that what? Like charge, repel. This repel, right? So this is pushing away and this is pushing away. Unlike each other, negative and positive charge attracting each other. This is fundamental law. You have to remember every time. Then I taught you about Coulomb's law that we'll be using it. Coulomb's law, we have its mathematical representation. This is the electric force, it's a vector quantity. Then we say that here we have proportionality constant. Then we have quantity of charge 1 times quantity of charge 2 over square of the distance between the centers of the charges, right? So you can also introduce a unity vector there and then put a square bracket, right? But that's the simplest form. Again, you have to remember about superposition. So superposition principle. Superposition principle. Superposition principle. What does superposition principle say? That if you are looking without antiforce, Fr, this will be the square root of what? Of summation, in sigma notation, of horizontal component of force square plus what? Summation of vertical component Fy square. So that is superposition principle. So well, I believe that now you are ready to carry on. We record some concepts of mechanics also, okay? The comparisons between electrostatic force and the gravitational force. We record the concepts of resolving angles. So today, I want to teach you another concept called determinations of the position of the point charge. So problem solving of electric force in determinations, okay? So let us start. So the first you say determination. Want to solve some problems in determination of 40 of position where no net electrostatic force. No net electrostatic force. No net electrostatic force. So he said that if two charges are spaced at a distance r, then there is a point whereby the electrostatic force is 0. What does it mean? Geometrically, suppose that this is the one of the quantity of charge and this is the one of the quantity of charge, right? So this is Q1 and this is Q2, right? So you can find if these point charges, right? These point charges, maybe that this is positive charge and this is positive charge, right? So positive charge and that is positive charge, for example, positive and negative charge. Yes, this is positive and this is negative. So what happens? So the nature of force here is attractive force. So this charge is attracted by this and this charge is attracted by this one, right? If now we have a said charge, right? We introduce another charge, and this is possibly positive, right? And this charge we got to keep. What happens there? This charge will be attracted on this side, but also it will be pushing. It will be also pushing by this charge. So this is force due to Q2, and this is force due to Q1. So what happens? So there is a point whereby this charge will not experience any force, right? So that's the case. So this is the possible area 1. But also, if in this point there is no possibility of having a native force to be 0, we can also test it on this side. So we can call this side B, or we can call the right hand side of this Q2. But also you can test it on left hand side. So it depends on the nature of the questions. You have to understand these questions are common and they are open. You have to understand them, so I'll teach you how to solve them, but I wanted to give you the general concept before we solve a problem. So let us say problem. So in this session, I'll be solving 3 questions for you. 3 to 2 questions. Okay. So this is the example 12. Example 12. Excuse me, this is not the session 9. This is session 8. So in the channel you find session 0 to session 7. Okay? Example 12 state like this. Okay? Calculate the position of the point on the line. Union charge what? Charge 1.67 microcoulomb. Okay, you will have physics and what? And negative 0.6 microcoulomb. Situated 0.4 meter apart. Okay, apart. So the question now, where are we? In the 30, it's a steady 20 charge. So charge. Say pointing charge means that point charge means that say the pointing charge Q does not experience, so does not experience what? Any force. Any force. And the question. Let us read it clear as physicists. Calculate the position. So the question asks us to calculate what position, not the electrostatic force, of the point on the line joining, on the line in between, and joining two point charge, positive and negative, situated 0.4 meter apart. Right? The first question. Where will the steady point? This is not in, it's not what? It's not the question. So at that point, so where will the 30-20 charge Q, where the 30, not where, excuse me, where the 30-20 charge Q does not experience any force. Okay, so because this is the first person, we can write concept. Calculate the position of the point on the line. Joining what? Charging 1.6 microcoulomb and negative 0.6 microcoulomb, situated 0.4 meter apart, where the steady point charge Q does not experience any force. So solution. Remember that in the style of solving physics problems. Steps, right? So you have the first step. The first step is, excuse me, my voice today is not good, but concentrate, you will get everything. Because the brain is okay, just the voice. And remember that Olenjolai does not know everything about advanced physics. I just know a small portion, but I'm ready. And it's my responsibility to teach others what I know in advanced physics. I'm still learning advanced physics, I love it so much. Okay, so the first step we say that represent the problem, okay, geometrical. Then the problem geometrical in two cases. The first case, so case one, we have a point charge Q and point charge this one. So this is the first charge, which is positive, 1.67 microcoulomb. This is negative, 0.6 microcoulomb. The distance between the centers, because we said that we measure the distance between the center of the point charge, according to this information, the distance between the centers is 0.4 meter. Right? 0.4 meter. So the distance between these point charges. Okay. If that the case now, we have to find that point. That's case one. So that the point in between, according to the formality, calculate the positions of the point on the line joining. This is the line joining. Joining what? 1.67 microcoulombs and negative 0.6 microcoulombs, situated 0.4 meter apart, where the set point charge does not experience any force. So it means that we say that case 2, this will be the second step, right? So we say that case 2, let the distance, right? The distance from point charge Q to 1.67 microcoulomb. 1.67 microcoulomb to be what? To be X. So if we represent the problem again geometrically, we have our 3-point charge now, right? We have our 3-point charge like this. And then we say that the distance from here to here, this is 1.67 microcoulomb. And this is point charge Q. And here we have the center, but also we have a distance from this one. This is negative 0.6 microcoulomb, right? So the distance between these centers we have let in the second step and you say let it to be x. The distance between 1.67 microcoulombs and negative 0.6 microcoulombs, we said sort it 0.4. So therefore, the distance again from this center of this pointed charge to this one, it should be 0.4 minus what? X. Right? Minus x. So that's the point. At the second stage. Then the steady state, we are going to test. Right? We are going to test. Okay. So remember that you have to be open-minded in these questions. Calculate the positions of the point on the line. He didn't say in between. The question didn't say in between. He said the line. So when they say the line means that in terms of the distance. We can have, this is the line in between, but also you can have line outside. The lines where along the lines mean that the line passes through the center of the charges. So this is, let's say, test 1. So this is, say, suppose this we call it in physics test 1. Because we test, we are not sure if this the point where we have what? We have a net force of 0, but I will show you. So we got the third state. The third state, we say that we call Coulomb's formula. Coulomb formula says that the force of attraction is equal to proportionality constant, quantity of charge 1, quantity of charge 2, over square of the distance. Right? So then we can use this one. Let us find, first of all, when we got the force state. The force state computed. Let us compute the force acting on Q due to Q1. So in order to do that, you have to let that the charge in Q is 1 microcoulomb. This is common, as I told you. So to find the force acting on point charge Q due to Q1, which will be repulsion force, and the repulsion there, to be 9 exponent 9 times what? 1.67 exponent negative what? 6 coulomb times what? 1 exponent negative 6 over the distance in between, which is x. Right? Which is x. Okay. So you can compute this force of the numerator, or you can leave it. You can compute or you can leave it. You have two options. Okay, so suppose that this is the first motion. Then we go for the fifth step. The fifth step, we say that let us compute it. Let us compute the force acting on Q due to, let's say, Q2. Suppose this is Q2. So this force will be what? Q1 times Q2 to be 9 exponent 9 times what? 1 exponent negative 6, okay, times what? 0.6 exponent negative 6 over the distance, which is 0.4 minus x squared. So this is square. So hopefully we might have the forces, but remember that those forces are meaningless if they don't obey the condition. Then we go for the sixth step on this second step. The sixth step, we say that now compute, let us compute it. Let us compute resultant force. Compute resultant force for instance for that. Resultant force for this case. What is the direction of this force? FQ Q1. So Q1 will be pushed in this direction. Right? And then due to Q will be pushed by 1.67 microcoulomb. What are the directions of the force acting on Q2? On Q. due to Q2, due to negative 0.6, it's a fraction force. So the force will be this direction. So this is force due to Q1, or force due to 1.67, and this is the force due to negative 0.6. So it means that the forces are in the same direction. So for instance, for this case, you say that FQ Q1 plus what? FQ Q2, which will never be equal to 0. It will be a resultant, it will be a certain value of what of force. So if not, it will not be equal to 0. So we say that there is no any possibility. So to solve this any possibility, there's no any possibility for the net force between, or for the net force to be 0 between what? Between 1.67 microcoulomb and what? 0.7 microcoulomb. And we have shown. So if this will not be, I think that you have finished to copy. In case you didn't copy, you can stop it and finish to copy and then you continue. I want to leave the question. So this case has failed, right? This case has failed. So if it has failed, you still have how many possibilities? 2. To test it, to take 20 Charlie Q to place on left-hand side of this or on right-hand side of this. So you have to test. It's your responsibility to do that. So we go for the 7th step. The 7th step, I say that this is test 2 and this is the 7th step. 7th step, say that test 4 Q to be on the left side of 40 of negative 0.6 microcoulomb. So if you do that, you will find this pattern. You have this fantastic pattern. So this is 1.67 microcoulomb, and this is what? Negative 0.6 microcoulomb, and this is point charge Q. So you have centers. And here we have centers. Okay? So we know the distance from this center to this center. The distance is what? 0.4 meter. Okay? So in order to achieve this, we say that let x to be distance from what? From negative 0.6 microcoulomb to what? So let this distance from here to here be x. So we cannot confirm until we see the chance of resultant force to be there. So if it is x, and this was no, actually. So this is still what? It is still the same distance, okay? Fine. So this is still x. This is still what? X. And this is point charge Q. Okay. So now, to complete the forces, we go for the 8th step. 8th step, we say that computing electric forces in between. Let us begin with electric force on Q, Q2, which is negative 0.6 microcoulomb. So this will be 9 times 9, then times what? Times negative 0.6 This is not negative, so negative 6. And then times punctuality is 1, so negative 6. Divided. The distance between them is what? Is x. So this one, it will be our third question. Then we can determine the resultant force acting on Q due to Q1. This one will be 9 exponent 9, then times what? Times 1.67, so negative 6 to negative 6, and this one we multiply with what? We multiply with this quotient, which is 1 exponent negative 6. The distance between Q and 1.67 is, excuse me, this is 0.4. It's 0.4. So the distance here, this is x squared into Coulomb. This is 0.4 plus x squared. So this one we call it equation 4. So now, how many equations we have? We have 2 equations there. Then the next point, you have to observe direction of the forces. Well, so the direction of the force between this point and this one is this direction. So it means to be attracted to this direction. So this is force due to Q2. And the direction between this point and this charge is still what? The partial. Yes, is it in partial? So the forces here are 0.6 micrograms per cube. So this one will be attracted. And this one will be, yes, so this one will be attracted. Okay, thank you, I saw it. So point Q will be attracted toward this by negative 0.6 microcoulomb. But this is positive 1.67 microcoulomb. And this is positive 1 microcoulomb. So the force due to Q1 to be acting in opposite direction. This is due to Q1, this is due to Q2. So the ninth step now is succeeded. Okay? So ninth step we say that F acting on Q due to Q1 is opposite. Is opposite to what? F acting on Q due to Q2. So if it's opposite, so we say that the resultant force is equal to F of Q1 minus F of Q due to Q2, and this should be equal to 0. Right? Because there's a possibility if they have equal values in magnitude, these forces have equal value of magnitude. We should place this Q in such a way that the force of repulsion between 1.67 microcoulombs and 1 microcoulombs will be equal to the force of attraction between negative 0.6 microcoulomb and 1 coulomb. Right? That the concept between. So if that's the case, if you say that the force acting on Q1 due to Q1 minus the force acting on Q due to Q2, this is equal to 0. So it means that you can say that FQ Q1, this will be equal to FQ acting on Q due to Q2. So if that's the case, what is FQ due to Q1? Right? So this is 9, 1.67, okay? Exponent 20 from negative 6, and then this we say times what? Times 1 exponent negative 6, and then so divide with what? The distance in between is 0.4 plus x squared. This will be equal to 9 exponent 9. Then you have what? 0.6 exponent negative 6 times what? 1 exponent negative 6 of what? Over x squared. Fantastic. Physics is beautiful. I believe that you enjoy it. Right? So you say that this one will cancel with this. Right? And then this one will cancel with this. Right? Again, this one will cancel with this. Right? And then we say that 1.67, right? 1.67, 10 of what? 1.67 over 0.4, 0.4 plus x squared. This will be equal to what? 0.611 over x squared. So this is equation. So remember that here we equated equation 3 with what? Equation 4. Okay? So this is cross multiplication. So to cross multiplication, we formulate a quadratic. 1.67 x squared, right? This is equal to what? 0.6. If you expand this one to 0.4 plus x times 0.4 plus x. So if you do this expansion, it is 1.67 x squared is equal to what? So 0.4 times 0.4. So you have to take your scientific calculator. It should be beside you. It should not be far from it. So this is your scientific calculator. So you take 0.4, we multiply with 0.6. So the answer is 0.24, right? So this one is 0.24. Then plus what? 0.6x. I'm doing this because many students, they are afraid of this, right? 0.6x, and then we have to multiply it with what? So this now is another expression. We have multiplied with 0.4x plus x. Or in other words, in other words, we say that we can put these expressions in this format. And you have 1.67, right? 1.67. You have 1.67 x squared. Okay, this is equal to 0.6. Expand this one. 0 times 4 times 0.4 times 0.4, that is 0.16, right? Plus what? 0.4 times 0 times 2. So it's 0.8x plus what? 0.4 squared. So we have 0.4 squared. Here we had what? Here we had 0.9. This is x squared. If you take 0.4, take 0.4 times 0.4, you get 0.16. Okay, so now we can expand and formulate our expression, right? How? Okay, enjoy solving physics. X squared. So we say that 0.16 times 0.6, which is outside. 0.6, yes. So the response here it is 0.09, 0.096 plus 0.6, okay, 0.6. Let me do quickly, 0.6 times what? 0.6 times 0.8. This is 0.48x plus what? 0.6 x squared. So then formulate a quadratic expressions. Take 1.67 minus what? I'm doing together with you, because many students, they used to say that, oh, sir, you didn't do the question on the blackboard. He was just copying answers from his exercise book. That's why that I failed in physics. For myself, I won't do that. So 0.20, I will be participating because I like 960. And this will be equal to 0. So now this is the quadratic equation. Let me check. 1.67. So now we can solve, press button, instead press. How we can solve? So we go to the what? This is the 10th step. 10th step, say that solve quadratic, which is question 5. Quadratic above. By using what? By using your scientific calculator. By using your scientific calculator. How? So the way that we do, you have to press this button of mode first time, second time, third time, until you see what equation. So you choose equation. How many degrees are unknowns? We have degrees. How many degrees? 2. The first one is what? 1.07. Then the second one is what? Negative 0.48. Then C is equal to what? Negative 0.096. So the answer is 0.56. The answer, so it means the value of x is equal to 0.56. Okay, 0.56 meter. That's the first value of x. This is x1 and x2. Press equal sign again. You get negative 0.145. Let's say 5 in 2 decimal places. So note, distance cannot be negative. Distance can be negative, whether in physics or in chemistry or whatever. So therefore, this is the distance now. So you say that the position, because the question asks you to calculate the position of the point. So you say the position of the point is 0.56 meter or 0.6 meter from what? From negative 0.6 microcoulomb. Okay? Then you are done. Was it interesting? Okay. So let me take you into the next example. And this is the homework 8 for you. So this is homework 8. Homework 8 for you. And this is our example 13. So let me give it down. Doesn't mean that I'm ending the session, but I'm giving you a related question so you can try yourself, because I want you to participate active in this program. So the question begins with this one. 2 point charges. 2 point charges of 10 microcoulomb and the 5 microcoulomb, 5 microcoulomb are placed. Okay? Are placed in 10 centimeter. Okay, 10 centimeter apart. In a vacuum. In a vacuum. Where should be? So the question, where should be? Okay, so this let's say point. Hence you have captured it W. Where should be a charge? Where should be a charge? of -3 microcoulomb. Be placed in order net force. So net force on it will be 0. Use not all, will be 0. But because of confusion, when you write, will be 0. So 2 point charges of 10 microcoulombs and 5 microcoulombs are placed 10 centimeters apart in a vacuum. Where should be a charge, means position, or 40 of -3 microcoulombs be placed in order? The net force on it, acting on it. Net force acting on it. Acting on it will be 0. So similar concept like what we did. Okay. Do you enjoy physics? Tell me in the comment section. Do you understand this stuff? Tell me in the comment section. Okay, I would like to finish this lecture or this session 8 with the following example, which is a conceptual example of a problem. This is example 14. Example 14. This concept. You have to be careful when you're solving, but also you can refer Advanced Certificate Secondary Education Review Book, okay, of the next exams of 2007. So you check which question, what the question number. The question states like this. Two similar balls of mass M are hung from silk thread of length R. And they carry a charge. Q. Assume theta is small enough. That such that tan of theta is equal to tan of theta. To this approximation, the above approximation show that distance x is given as numerator that quantity of charge q times a, this is r, or a not q, divided by 2 pi permittivity of the free space. Then we have mass m and then times bracket. What? And the so whereby at is equal to distance of separation. Let's see how the questions are asked. Let us read and solve it. It's not a hard question. Example 14, concept refer advanced certificate secondary education examination 2017. Two similar balls of mass L are hung from a silky thread of length R and carry a charge Q. Assume theta is small enough that tan theta is equal to sin theta. To this approximation, show that x is equal to q squared times r, where r, length of the thread, length of what 2 pi unit of free space, m stands for the mass of the ball, g stands for the acceleration of the gravity. So the first approach of these problems, if you want to solve, you have to sketch the problem first. So solution. This I will solve because I know if I leave to a challenge. But in case you want to try, you can pause the video, you try to solve yourself, and then you check the answers. The first step, I say that you prevent the problem. Then the problem geometrically. How? We have a triangle, and this triangle representing threads. Okay? So this is the point where the thread holding these two balls is sustained. So two similar balls of mass M are hung from the silky thread of length R. So the distance from here, these are the similar thread, is R. And this is what? Thread. Silky thread. And even this one also, it's what? It is a silky thread. And here the distance is 7. Here we have our charge, our two balls of mass M. We have our first ball, this is our second ball of mass M, and carry a charge Q, right? So instead of, so you have mass of M, and then you have charge of Q, each of them. Okay? And carry a charge of Q, assume that theta is small enough that tan theta is equal to tan theta. This is for the small m. So here you can resolve a right angle triangle. Here we have angle theta, and here we have angle theta. So what the distance between them? That's the question. What the distance between them? We don't. So this distance between them is what we call x. So where x is the distance of separation. Thank you. X is the distance of separation between these point charge. So this is x. So if that's the case, if this is A, B, label C, and this is D, then we say that that is x. So here we have x over 2. And there we have x over 2. So now the next step, we have to resolve these forces. So to resolve the forces, I told you in previous examples, don't want to waste time to revise or to teach you what I've already taught you and you've understood. We have four forces acting on disparate charge or disparate charge, right? The first force is the weight, which is mg. Then here we have the vertical components, which is the cosine function. So we have tension. So this string should have a tension. That's like a strings instrument. So tension times cosine of theta. And then this one is T, then times 30, then of theta. Right? And here we have force of 40, force of repulsion, which is directing this one. So that's the first process. In case you have any questions concerning about those processes that I have done, you can ask your question in the comment section. Okay, so this is our question. So this is the homework. I believe that you do it successfully. Remember, in case you want to offer God your free will in thanksgiving in order to participate or in order to be a part or to support the running cost for this program. Free willing thanksgiving. So you got that. This is the first step. The second step, after presenting numerically, you see that now life is simple. We simplify. This has been a complex problem in way rather than presenting it numerically. So the second step, we say that at equilibrium, where there's no any further repulsions, attractions, and whatever, we say that all forces on Q balances. So if it balances, we have horizontal forces. Horizontal forces is due to the force of repulsion. This will be equal to what? It will be equal to the tension and sine of theta. This is our first equation. Then our second equation. Our second equation, this is horizontal. Vertical. Vertical is say what? So you have two forces also which have to balance. The first one, we say that weight mg should balance with t cosine of theta. This is the second equation. So from there, we can get a piece of information that has been given here. So we go for the third step. We show it this one. So in the step, we say taking question 1 equal to question 2. No. Do an operation. Taking question 1 divided by question 2. So if you take question 1 divided by question 2, this force will be mg, and there we have what? T sine of theta over t cos of theta. T and t cancel. Sine over cosine, remember loss of 2b. Put in your O level, so you make it tan of theta. Okay? So if that's the case, you say that the electrostatic force of repulsion, for this case, mg, this is equal to tan of theta. So if that's the case, you say the electrostatic force of attraction is equal to mg tangent of theta. So again, this is the third equation. What else? We want to show that that expression is equal to this. Okay. So then we have to think about what? Tangent of the angle. We have tangent. So this is the first step. Tangent of theta. Tangent, for instance, consider this right angle triangle. Right? Tangent of this angle theta. It will be what? Opposite over adjacent. Opposite of what? Of adjacent. for this case, let us find tangent of this M, either this or this one, right? So we say that tangent of what? Of angle theta, in this case, is equal to opposite, which is x over 2 of what? Over adjacent, which is r. So tan of theta is equal to x over 2 divided by r. And the answer is, we say that tan of theta is equal to x over twice r. X over twice r. Okay, let me clean this part. So, this is equation what? Equation 4. Fantastic. So you go for the physics step, still solve. Physics is beautiful. Advanced physics is very beautiful. Say that now, substitute equation 4 into equation 3, right? So to substitute, you say that force is equal to what? mg mass times gravity. In the positions of tangent, we put x over 2a. This will make what? Mass times gravity x over twice a. So this is our force. Our force is equal to mass times gravity times distance x between the points, and this will make the sixth equation. Fifth equation. So you go for the sixth step. The sixth step, we said that we have to recall Coulomb's formula. Coulomb's formula. To recall the Coulomb formula, we say that for this case, force of electrostatic is equal to proportionality constant K, right? And hence we say that Q1 times Q2 over R squared. K is equal to what? K it is 1. So Q1 and Q2, these are like similar balls. So it will be Q squared. K is what? Remember that K is 1 over denominator of what? 4 pi, the magnitude of free space, then square of the distance between them. That's the force. Right? So you say that this force is equal to what? Is equal to Q squared of what? Over 4 pi, the magnitude of free space, then square of the distance. This is question what? 6. Question 6 is equal to equation 5. So we go for the 7th step. The 7th step, we say that take equation 6, equation 5, equate with equation 6, mathematical. They are equal. So if you equate, we have mass and gravity x twice a. This will be equal on right hand side, which is q squared over 4 pi, permitted of free space, square of the distance. So 2, we divide by 2, most denominators, then we have mass x over a. This is equal to q squared of what? 2 pi, permitted of free space, r squared. The question asks us to make x the subject. Make x what? Subject. Make x the subject. But before we make X the subject, is the 8th step. What the distance of separation between two similar charges is what? It's X. So we say that let R is equal to X. So in that case, on the left hand side we have mgx over A is equal to what? Q square twice 2 pi perimeter of free space x square. So cross multiplication. If you cross multiplication, this will make 2 pi perimeter of free space mg x cubic is equal to Q square times R. Make x cubic the sum. 2 pi times perimeter of free space mg divided by 2 pi perimeter of free space mg. So we get what in our x cubic. But if you've copied it, you can pause the video and finish the copy. Physics is beautiful. So if that's the case now, on left hand side we have x cubic, x squared times r, and then we say that we have again what? 2 pi, vector free space, then mass, gravity. So to find this, we say find the Q root. Find the Q root on left hand side and right hand side. So x is equal to the Q root of what? Q square A over 2 pi vector free space mg. In other words, this is equal to x Q square over A 2 pi infinity free space mg power 1/3. So hence shown successful. And this is the end of this session 8 or lecture 8 of electric force, right, in electrostatic. I would like to thank God who have been with me since the time of preparation for this session 8. God has been faithful. He taught me many concepts, and I thank Him because He has been faithful, and I taught you all of those concepts so that you may go far as well as you can. I thank God for you, and I thank you also for taking your time to learn with me. I invite you in the next session, which will be lecture 9, which will be keep on learning the electric force. And then we jump to later on we go to lecture 10, where that I'll be teaching about electric fielding, that the third topic of electrostatic. So may God bless you abundantly. Keep on praying for me, and I will keep on praying for you. May God bless you until we meet in the next session. Be blessed abundantly.